Let's look at a binomial probability problem that might be a little trickier. This one spells out p, n, and x for us. So it says we want the probability of x being greater than or equal to 4, n equals 7, and p equals 0.5. So coming up with those numbers is not the issue here. The issue is that if we look at x, it says we want x to be greater than or equal to 4. Okay, if we're using a formula, that can make this problem really long. But really, having x be a range of values is not that tough, because not only do we have the binomial probability table, we also have this table called the binomial cumulative table, or the cumulative binomial probability table. And the idea here is that if we go to the cumulative table, any x we look up is going to include not only the probability of that x, it's also going to include the probability of all the possible outcomes below it. Okay, so in other words, we're looking up the probability of x being less than or equal to whatever x we look up. The issue we have here is that we don't want x to be less than or equal to some number. We want x to be greater than or equal to some number. So we have to put a little bit of thought into this before we get started. So let's look at what's going on here. We have an n of 7, and we're looking for 4 or more successes. So if we list out the possibilities here, we've got up to 7 successes. Okay, and we're looking for this case where we have 4 or more successes. So in other words, we want the probability that x is greater than or equal to 4. Okay, we can't look that up directly in the table. Okay, but what we can do is we can kind of think backward. Okay, so if we're trying to find the probability of x being greater than or equal to 4, let's think about what's left over. So our other possibilities, okay, if we think about the probability of those possibilities, we could call this the probability that x is less than or equal to 3. And the idea here is that if we think about the probability of all the possible outcomes, we add all of those probabilities together, we know what we should get. We should get 1. Okay, that's our maximum probability, the total probability. So if we're a little creative here, if we want to find the probability for x being greater than or equal to 4, we can figure out that that is 1 minus the probability that x is less than or equal to 3. The good part is that we can look up this blue probability. We can look up x being less than or equal to 3 in the table with no problems. So if we look back at Hawks, we have an n of 7 and a p of 0.5. We can go to our cumulative binomial table. N of 7, p of 0.5. And remember, we're looking up the opposite of what we want. Okay, so we're going to look up the probability that x is less than or equal to 3, which in this case turns out to be 0.5, or 0.5000. Okay, so if we go back and we plug in here, then the probability we want is 1 minus 0.5000. Just a coincidence, it came out to be exactly 0.5 on that one. Then when we subtract, we get 0.5000. Okay. You won't always get the same thing there. It just worked out that way on this one. So our answer, we can close out our table, is 0.5000.